Welcome to the Explainer. Go ahead, grab your virtual coffee, get comfortable, and really get ready, because today we are stepping into the absolute core of ethical hacking. If you've been following along with our cybersecurity journey, you know we've talked a lot about theories, mindsets, and networks. But today we take off the training wheels together. We're going to master the Linux terminal, specifically focusing on bash basics. This is literally where the actual work happens. So let's just dive right in and get our hands dirty. Take a look at this. We've got a pretty stark contrast here. On the left, there's the GUI, the Graphical User Interface. This is what everyday users rely on. It's exactly what operating system creators want you to see. It's super comfortable, full of pretty icons, entirely clickable. But to a cybersecurity professional, it's slow. And honestly, it is severely limiting. It basically only lets you do what the developer pre-programmed you to do. Now, look on the right, we have the CLI, the command line interface. This right here is where the real power lives. Sure, it might look a little intimidating at first, just raw text on a dark background, but it is lightning fast. It's direct. In the CLI, you aren't restricted by menus, you're literally only restricted by your own knowledge. Section 1. The GUI illusion. Peeling back layers. Okay, before we completely shatter that GUI illusion, we need to establish a very crucial boundary. Welcome to your legal, authorized Kali Linux lab. The skills we're about to cover, they give you incredible access and control over a computer's file system. So, as ethical hackers, we must absolutely only ever use these commands inside our own authorized virtual labs like Kali Linux. We never ever test on real public websites or unauthorized machines. Remember, we are learning to be the shield, not the sword. So keep it legal, keep it ethical, and keep it in the lab. Section 2. Entering Bash. Step into the matrix. So when we open up that black window, we're using Bash. Basically, Bash is the command language used to speak directly to the Linux kernel. Think of the kernel as the absolute brain of the computer. When you use a graphical interface, you're asking a program to ask another program to ask the kernel to do something. It's kind of like a massive game of telephone. But with Bash, you are bypassing all of those graphical interfaces and speaking the machine's native tongue directly to its brain. No translations, no middlemen, no delays. But, that raw power definitely comes with the challenge. You've opened the terminal and it's pitch black. There are no folders to look at, no My Documents window, no back buttons, just a blinking cursor. I mean, if you were dropped into a pitch black physical room, your very first instinct would be to feel around and figure out where you are, right? Well, in the terminal, how do you orient yourself without a visual map? How do you know where you're actually standing inside the computer's memory? Section 1. Essential Commands. Turning the lights on. All right, here is your very first survival toolkit for the terminal. The absolute first thing you do in that dark room is type pwd, which stands for Print Working Directory. This command simply asks the machine, hey, where exactly am I standing right now? And it prints your current location right there on the screen. Okay, so once you know where you are, you type ls, which stands for list. Think of this as shining a flashlight around the room to identify all the targets, files, and folders sitting right next to you. And finally, once you see a door you want to actually walk through, you use cd, change directory, to move your position forward into that new folder. Seriously, these 3 little commands completely replace your computer mouse. And listen, this isn't just about memorizing vocabulary. It's about sequence. This builds into a methodology, what we call your basic hacker recon move. Step 1, PWD. Locate yourself. You've got to always confirm your starting point so you don't accidentally execute a command in the wrong place. Step 2 is LS. Observe your environment. What files are vulnerable? What directories are available? And then step 3, CD. Make your tactical move to the specific target directory. This 1-2-3 rhythm, locate, observe, move, is a loop you are going to run thousands of times as a cybersecurity professional. It literally becomes muscle memory. Section 2, Navigating with CLED, Mechanics of Movement. Now, it is so easy to get frustrated right at this stage, so let's save ourselves some major headaches and look out for these fatal rookie mistakes. First up, Linux is strictly case-sensitive. If we try to cd into a folder named desktop with a lowercase d, and the folder is actually capitalized desktop, well, Linux is just going to look at us blankly and tell us that file doesn't exist. It does not guess what you mean, it absolutely demands precision. Second, notice the formatting here. Always remember the space after the cd command before you type the folder name. Cd space desktop works perfectly. Cd desktop all mashed together does not. And lastly, a final, absolutely crucial reminder. Never practice these commands on a system you don't own or don't have explicit permission to test. We always stay in the lab, for sure. Section 3. Hacker Milestone. Finding Locked Doors. Okay, if you've been following along in your Kali virtual machine, congratulations! You have officially navigated a raw Linux file system using nothing but bash commands. You've totally stripped away that GUI illusion. You've mapped the room, and you know how to walk around. But what happens when you find a locked door? Because believe me, the most interesting files in any system, the password hashes, the server configurations, the root directories, they are all hidden behind thick cryptographic doors. You can run an LS to see them sitting there, but if you try to CD into them, the system is going to hit you with a big, fat, permission-denied error. And that actually brings us to our final thought. The quote here says, "You know how to walk the halls of the terminal now. Next time, we learn how to own them." Being able to move around is really just the prologue. To truly secure a system or to ethically test its vulnerabilities, we really need to understand who owns what and exactly how to elevate our privileges. How do we actually convince the Linux kernel that we hold the master keys? Well, we'll be breaking down file permissions, user groups, and the legendary sudo command in our next explainer. Until then, keep practicing those recon moves in your lab, and I'll leave you with this challenge. If the GUI is an illusion designed to keep us safe, what other invisible walls are built into the devices we use every single day? Think about it. See you next time.